All right, here's another big buck converter I'm making for another QCW at some point. I really like this setup just because, I don't really know how well it works yet, but I like it because it's largely from recycled parts, right? So pretty much the majority of this whole thing, which does include a full bridge down there, pretty much all came from old VFDs, right? Starting over here, I'm gonna have different inputs right now. Just sort of got it bootlegged up with 120 input, three-phase bridge rectifier, a couple discharge resistors. So basically what I'm doing here, I'm gonna have a 24 volt control power, and that's gonna feed into this little relay guy. So that just uses a normally closed contact to put those discharge resistors on the cat bank. Can only charge them up when I've got control power, basically. The full bridge over there is using a couple FUJI bricks. They're like 1200 volt, 300 amp deals. I'm not sure how well they're going to work up to whatever frequency I go with, but just figured I'd test them out because I've got quite a few of those. If they work pretty good, that'd be pretty awesome. Couple stacked big cores there, same ones I was using before. I actually need to rewind that with some thicker wire if I can, but that's all I had. Big switch here, and the same two big caps I was showing earlier, two 5000 microfarad. Decided to just use two. I could stack up to four. I might go with three, but figure we'll just see how that works with the 10,000. That switch, I'm not quite sure the rating on it. It's probably like 1200 volt, 300 amps, something like that. But again, it's just a big single switch, so decided to use it. And just a bunch of thick wire here, right? I've also got a 2.2 ohm load resistor on the output of the Bucks. Pretty much the beefiest, lowest value resistor I've got laying around. Aside from just trying to use a piece of wire or something. So that thing will get hot. I don't know if it's actually going to burn it out. All depends on the duty cycle, frequency, whatnot, how high I actually go in the voltage. But 2.2 ohms, let's just say that's about 2 ohms. I put about 40 volts across that thing peak. It's going to be about 20 amps. All right, so I'm just going to bring this up a little bit here. Got the scope on the output. That's the voltage on the caps. I'm going to use this ramp generator. So I've just got that feeding into this little bootleg gate drive circuit right here. And I got the logic supply. So let's see. Well, let me just put that at 24 like I plan on. So about 24 volts, got that going. And cut this on to get the caps charging. So let's see, just bring them up to like 20. Now let me bring it up to like 40 volts, something like that. Ramp up. So that's the shortest on time. I'm just gonna bring that up to well, let me see what it's actually at. I'm gonna bring that up to like 100. Because again, this is all kind of bootleg right now. Haven't really thought it through. I don't want to pop nothing. Bring that up again. So do about 40 volts. Well, do 60. So that's only about 30 amps. Increase the on time. Hear the variac starting to hum a little bit. Bring the step up. Not totally sure what all that tiny little noise is there. I seem to see that sometimes. Sometimes I don't. So let's see, with 90 volts, let's say, or about 100 volts or so. Let me get this thing going. The speed will pick it up. All right, so what am I at? 20. So yeah, I can go up to about 80, looks like, before it starts to slope over with this load. That's not bad. So yeah, I'll have to do a little tweaking on there, get it cleaned up a little bit, but it seems like it'll work all right if I have those caps all the way up. But right now with this 2 ohm load, yeah, about 100 volts, with that on time, well shit, if I drop the on time, then yeah, looks like I can get pretty damn near close to 100 volts. Cut the variac off. So you can see there's no, really no bleed down. It's just self-discharge. And, oh, that's actually already pretty damn hot. It's interesting how that works. So yeah, that thing got hot real quick. And as soon as I just cut control power off, that relay is going to close, and now it's bleeding down. So again, that's a good thing I would recommend to do. And you can actually, I tell people all the time, it's real easy. They got a capacitor, discharge, resistor calculators online nowadays, right? So you could just easily solve for resistance or discharge time and really get an idea of how that works. This particular setup, if I've got this charged at about 350 volts, probably about the max I'd bring it. It should bring that down to about 50 volts in about 40 seconds with about 2K discharge resistor, right? So that's pretty cool.